So 6.1 deals with rational expressions and functions, simplifying, multiplying, and dividing. Please understand that a rational expression, it just means you're going to have something in a form of a fraction. This is what we're going to be doing today. We're going to have to factor both the top and the bottom and see if it's possible. This here is a rational expression. It's just a random example, just so you know what we're going to be doing. We're not going to be able to do anything with that one. That right there is a rational expression. Rational is like a fraction. Now, there's only one question on your assignment that's asking for the domain. When you look for the domain of a rational expression, and I'm going to write it out, what you're doing, because if I say it, some of you are still going to be like, huh? So, domain of a rational expression. It is all the possible x values that do not make the denominator a zero. What happens if you have a fraction and your denominator is a zero? Is it zero? Undefined. It's undefined. So you can never have a zero in your denominator, and that's what you're trying to figure out. Which numbers make it a zero? Because it's going to be every number except for that. So the domain of a rational expression, all the possible x values that do not make your denominator zero, because if the zero is in the bottom, it's undefined. So in the first example, we have to find the domain. And I only have one problem I'm doing with you, one that you have to do on your own. But if you think after two it's not good enough, then please ask for another one. They're going to give you a problem that looks like this. The only part that we are concerned with, according to the definition of finding the domain, is your denominator. That's it. So even though they give you a rational expression, what is the only thing you have to focus on when they're asking for the domain? The bottom, right? So it's x squared plus 8x minus 20, and we're going to set it equal to 0. So we're going to do factoring. We're going to have to solve for 0, and that's going to give us the answer. So when you look at this, I'm looking for the numbers that multiply to a negative 20 and add up to 8. Then I have 1 and 20, 2 and 10, and 4 and 5. It's 10 and 2. It's one of them has to be a negative. It has to be the small one because your bigger number has to stay positive, right? So this one gives me an 8. I have x minus 2, x plus 10 equals to 0. So x minus 2 equals to 0, x plus 10 equals to 0. When you solve each one, this becomes x equals 2, and this becomes x equals negative 10. So if I were to plug in a 2 in here, it's going to give me a 0 on the bottom. If I were to plug in a negative 10 in here, it's going to give me a 0. So what is my answer going to be, knowing that I have this? The answer will be the domain, and this was supposed to be f of x equals to that. So the domain of f of x, meaning this entire thing, is all real numbers except, and this is why you have to do this. On your My Math Lab, this is already going to be typed in there. There's going to be a little box, and it's going to say separate your answers with a comma. So my answer is going to be 2, negative 10. The domain is every single number except 2, negative 10. No parentheses. You just write it out just like that. So this sentence is already there. They're gonna give you a function. You just need to do that. Have we done this already? Yes, so this is nothing new. It's just now this leads to an answer from here where it tells you your domain is everywhere except when x is 2 and x is a negative 10.
This makes some sense, but all real numbers is anything that isn't like percent or decimal?
All real numbers, it's like a -2, a -5, a -20, a -2.5, like any number on the number line. It has nothing to do with percent or decimal. It's just with the number line itself. So let's try one on your own. 4x plus 3, x squared minus 9x minus 22. So only one question out of the 13 for this assignment deal with domain and range that I saw. Only one question. So you're looking for your domain, you have to take your denominator, set it equal to 0, find the two factors, work on it a little bit, please. Are those the two answers you guys got? Yes? So once again, this is gonna be the same sentence. The real, the domain, f of x.
This square would be -11 positive 2.
It's a -9.
If it's one only, the bigger number would be negative. And the smaller
The
would be
bigger
positive.
number is negative in here,
Yeah.
but when you set them
so
equal to
yeah.
0, you have to solve.
Yeah.
So, and right away, that's what you guys do. You start doing this and you're like, oh, it's a -11, x equals 11. Remember that this gives you your factors. You still have to set them equal to 0. So the domain of f of x is all real numbers except 2, -11. Questions on finding the domain? Is everybody comfortable with that? Yes? All right. So once again, if you're good at factoring, 6.1 is not going to be that hard. It should be fine.
Isn't it, wait, -2, positive 11?
Yes. Oh, see, I was over here confused. These are your answers. -2 and a positive 11. So sorry. I apologize. Yes, it was, Mario. He confused me. I'm going to blame it on you. Because it's easier always to blame someone else. All right, so here it is. -2 and a positive 11. Those should be the answers here. All right, for example number 2. Example number 2. Simplify a rational expression let's start off with something smooth. Let's look at this problem. When you see 5x plus 10, that's one expression. When you see 5x squared minus 20, that's another one. You factor them individually, not together. So if I look at 5x plus 10, And this is my problem, but I'm gonna do some work over here before we do anything. What can I factor out from here? A 5, so this becomes 5 parentheses x plus 2, yes? All right, so that's one part. Now let's look at the bottom part. Can I factor anything out from here? A 5 also. So this becomes x squared minus 4. Can I do anything else to this? This is a difference of squares. So what does this x squared minus 4 become? X plus 2, x minus 2. You need to factor all the way to be able to figure out, can I do something? So now that I have this and this, I'm going to rewrite as a fraction. So I have 5 parentheses x plus 2, 5x plus 2, and x minus 2. So once you have factored out the top and bottom, and then later you're going to have to do 4 things that you're factoring out, just letting you know the problems do get bigger as we go. You see whatever's in common on top and the bottom, and you get to eliminate them. So I have a 5 here, and I have 5 in the bottom, so we kiss them goodbye. I have an x plus 2 here, and an x plus 2 here, you kiss them goodbye. Now, the only thing I have left is an x minus 2 in the bottom. There's nothing on top, but you cannot leave it as nothing. When everything eliminates, you're going to have to put a 1. This is going to be your final answer for this problem. So, once again, you take your numerator, factor out what you can. You take your denominator, factor out what you can. Then you write them the way they're supposed to be, one on top of the other, and you start to see, hey, what can I get rid of here? Questions? No? This one's more challenging. 2x squared minus xy minus y squared divided by x squared minus y squared. So let's take, this is my problem, I'm gonna box it. Let's take this problem here. Even though you see a y squared here, please understand there is a -1 there, right? I make a table. You have a number in the front because you can't factor it out. This number times this number gives you a -2, and this is a -1. What two numbers multiply to a -2 that add up to a -1? 1 and 2. Who has to be your negative? The bigger number. That way I get that. So when I do this, this is x plus 1y, x minus 2y. Now, usually we just put the number, but why am I putting y? Because what do I have here? A y squared. But am I done? Do I just do that? I have to divide, because what did you do at the beginning? Can 1 be divided by 2? No, so it becomes 2x plus y, or 1y. If you want to put it, can 2 be divided by 2? So it just becomes x minus y. Once again, it's a little bit different because they added the y and the y squared, but it's the same process. You multiply, you find factors, and then you divide. Now, this is just which part? The top. So I still need to figure out the bottom part. So my bottom is x squared minus y squared. Say,
Couldn't you factor both?
you can't factor.
Well, like, it would be like x minus y, and then x plus y.
Plus y, yep, it's a difference of squares. There's a 1 here, square root of it is 1, 1, square root of that, perfect. So this is your bottom. Now I'm gonna write it as one whole thing. which is 2x plus y in parentheses, x minus y in parentheses, x minus y, and an x plus y. So once again, if you have the same thing on top, same thing in the bottom, you're allowed to cross them out. 2x plus y, nope. X minus y, yes. What's your final answer? 2x plus y over x plus y. Cross out the y's?
Yes.
No, because the 2x plus y is together. The x plus y is together, and this is why I went back and I put parentheses.
Whatever you, like, let's say this is on the test, do you have to have the parentheses?
If you have more than one thing, like if you still have like another parentheses here, yes, I need to see that, because I need to see who's with who. But if your answer would have been like this, and you would have just given me that, it would have been, I'm not gonna mark it wrong. And you'll see what I'm talking about in a little bit. How about try this one and see how far you guys can get. X squared minus 36y squared over x squared minus 3xy minus 18y squared. So it's the same type of problem as B. Same type of problem. It's just flipped around. Difference of squares is on the top and the other one's on the bottom. Take one, take the top, factor it out, take the bottom, give it a try. You're looking at it and you're like, oh crap, this is gonna be a lot. But once you get in there with your little boxing gloves, you're gonna be fine. So did we get this one for the top? Yes? The bottom one, I have to use these two. So it becomes a plus 3 and a minus 6y. Yes? Bottom, top, we write it out. X plus 6y, x minus 6y, x plus 3y, x minus 6y. Do they have anything that's the same on top and bottom? So my answer, x plus 6y, x plus 3y. I prefer to see parentheses. Me. Is there a question on how did you get this? No? clarification on some things. I'm not just here to feed, but I'm also here to break it down into little pieces if you're choking. I don't want you to choke. I don't have time. Yes.
So we do parentheses on each of them as a separate expression, we can't do it as an expression together.
Like this whole thing together?
Well, like, just like parentheses around the entire fraction. Like one big parentheses.
Like one big, you can, because that would mean it's the top by itself and the bottom. But right now that we end up with, because there's gonna be some problems where you're gonna end up with 2, 3 things on top and 1 or 2 on the bottom. That's why I need to see them.
Separated.
Yeah,
Okay.
that's the only reason. Alrighty, so, yes, sir.
Can we go back to the other examples? 5x plus 10 over.
This one?
I get how you got the answer.
So the only thing that these had in common was a 5. So I factor out 5 from both of those, right? So 5, if I take out 5 from 5x, I have x. 10 divided by 5 is 2. So we're okay with this part. Then here, we factored out a 5, but when I factor out a 5, I still end up with this expression that could still be broken down because it's a difference of squares. It's a -4, I take the square root of it, there's a 1 here, you can take the square root of that. So this is why it becomes x plus 2, x minus 2. Then we put this one on top because that's what was on top, and we put this one on the bottom because that's what was on the bottom. And then we start to see what they have in common. Now, anytime that everything eliminates either on top or bottom, you don't put a 0, you have to put a 1. So here, both things on top got canceled, so this is why we still had to put the 1. What did you have left over in the bottom? An x minus 2. You sure? All right. 2x minus 3y over 2x squared minus 7xy plus 6y. When you look at this problem, you have a top and you have a bottom. But when you look at that top, can you factor anything from 2x minus 3y? No, so you don't have to worry about doing any work there. The only one you're gonna have to do some work is going to be the bottom part. So I have a 2x squared minus 7xy plus 6y squared. Now, the thing here is what can you factor anything out there? Nope. So this is a problem where I have to do this and do what? So my new last number is going to be 12, and my middle number is 7. So 1 and 12, 2 and 6, and 3 and 4. It's a positive 12. So they're both going to be the same sign. This is a negative 7, so that means both need to be negatives. When I add, negative 13. When I add, negative 8. When I add, a negative 7. Who gave me the negative 7? X minus 3y. X minus 4y. But I need to do what with it? Put the 2 underneath. I have to divide by 2 because I multiplied by 2 first. Very good. Can 3 be divided by 2? So this becomes 2x minus 3y. Because remember, if you can't divide, it goes to the front. Can 4 be divided by 2? Yes. Now, I've done what I should have done. The tops is a top. We didn't do anything to the top once again because you can't. This, I'm going to rewrite in the bottom. 2x minus 3y, x minus 2y. Do we have anything that's the same? 2x minus 3. There's nothing left on top, so what must I put? A 1. x minus 2y. Yes?
So how do you know you're gonna be able to comprehend?
Because there's nothing that we could factor out. The 2 and the 3, we can't factor out. One has a y, one has an x. We can't do anything. You just need to simplify if possible. So if I were to give you 10x minus 6y, both of those are divisible by 2. So then we could do something here. So you just try to see. If not, you leave it alone. If possible, then you do something. Okay? X cubed minus 4x squared minus 5x over 3x squared minus 30x plus 75.
You said when you can't divide, the number goes to the front of the expression.
If when you cannot, like here that we couldn't factor anything, then you multiply the top times
You want it, the 3 divided by the 2.
the,
When you're
oh, here,
simplifying
yes,
it,
yes. Here, when you can't, when it doesn't divide equally the way that did here, it goes to the front.
But you still divide the other.
Yeah, the other one still divides. And sometimes it doesn't divide equally, but you could reduce a fraction. So maybe, hopefully we will run into one of those today. So am I gonna be able to do work with the top and bottom here?
Yes.
Yes. Let's look at the top one.
Won't you have 3 answers for this, for the top?
I don't know, we'll see. We'll find out.
Turkey.
It's, maybe. So what do we know about the top? Everything has a who. So that's the first thing we have to do, factor out an x. Okay. My last number is a -5, middle number is a -4. The only way I could get a 5 is 1 times 5. What do we do here? Who's negative? The big one, right? Very good. So this becomes x plus 1 and an x minus 5. So I have 1, 2, 3 things the way Kelsey said. Very good. So this is going to be your top, but I still need to work with what part? The bottom. So let's look at 3x cubed minus 30x plus 75. Looking at 3, 30, and 75, is there something I could do to factor out?
Factor in 3.
A 3. Every single of those numbers is divisible by 3. So 3 parentheses x squared. 30 divided by 3 is a 10x, and 75 cents divided by 3 is how many quarters? 25, right? So 3 quarters give you 75. Then I look at this, my last number is 25, middle one is 10, 125 for 5 and 5. But they both have to be what? Negatives. So this is going to become 3x minus 5, x minus 5. So this is my top, this is my bottom. X plus 1, x minus 5, for some reason that's 3, x minus 5, x minus 5. What does the top and the bottom have in common? Just 1 x minus 5. You cannot cancel 2 for 1. It's 1 for 1. That's it. So my leftover answer, x plus 1, 3, x minus 5.
So like, let's say if, like, the bottom didn't have anything in common with the top except for like a x plus 1 was also on the bottom, could you write 3x minus 5 squared?
Can I write 3x
Like if you had two of the same bottoms,
So if I had another x plus 1 here,
or like, let's say you didn't get rid of that x minus 5, and if they were both still left there.
you would write them both. You would write them both. Mhm. So whatever you don't cross out, you have to write it in your final answer. All right, the next one's a little curveball. I don't know if you're gonna have anything like that in your assignment, but just in case it does appear, I didn't wanna not do it. And then you were gonna keep getting that question wrong. So please notice, first of all, they switched the y's and the x's here in this problem, because they're just evil people. And this is a 14. Yes, my bad. I wrote it together and that's why it's all crumbled up. It's a minus 14. When I wrote it on my paper, I put the minus and the 1 together and it looked like a plus 4. Minus 14. All right, so can we do anything with the top? Yes, it is a difference of squares, because can you take the square root of 25? Can you take the square root of 16? So 25y squared minus 16x squared becomes 5y plus 4x and a 5y minus 4x. That's going to be the top. You can take the square root, you can take the square root, and there's a minus. Anytime that you have that, that is a difference of squares. Then I have 8x squared minus 14xy plus 5y squared. Can I factor anything out from those? No, not a number, not a variable. So I have to take the first number times the last one, which now gives me a new number of 40 and negative 14. 140, 220, 410, 58. They both have to be what? Negatives, because it's a positive 14 and we have a positive 40 and a negative 14. Yes, it is that one. X minus 4y and a x minus 10y. But now I need to not forget that I need to do what? Divide by 8. So this is what I was telling you earlier, Summer. 4 does not divide by 8, but I could reduce that to a half. So now the number that goes in front is going to be a 2, not an 8. So it would be a 2. 2x minus 1y. And 10 over 8 reduces to 5 over 4. It would be a 4x minus 5y. Oh, yes. This one's the one that goes to the front, that's the one that goes to the front. So this is my top, this is my bottom. And I'm gonna write them here because we're still gonna have to do something else. And a little bit. When you look at this, can you cancel anything? No, right? Because first of all, I have a 2xy, there's no such thing. These kind of look the same, but my 5 is what here? A negative. So if I were to do this to the bottom, take out a negative 1 from this part, that 4 is going to become what? Negative 4, and that 5 is going to become a positive. So this is a little curveball where you could do this if needed. And I'll put that there. Everything else kind of stays the same. Once again, let me say this again. Because if I divided this by a negative 1, which is factoring out a negative 1, my signs change. And now I can look at this and say, hey, you could cancel those because you have a positive 5y and a negative 4x. So those go goodbye. What's left over? 5y plus 4x, 2x minus y, but please don't forget this negative out in the front. Now, if you wanted to, you could put the negative on top, negative in the middle, or the negative in the bottom. As long as somewhere, there has to be that negative. Because this negative one that I use to allow these to eliminate. So that is the curveball right there. One more for this section, because this is going to be problem number 3 on your assignment. All right. Any questions on DEF? So once again, we factored out a negative 1 to allow those to eliminate.
Is it still 6.1?
Huh?
Is it still 6.1 number of unfinished?
Yes, and there's still more, there's a lot. This is crazy. What letter was I on?
F.
F, so this is G. If I know my alphabet. 6x squared minus x cubed minus x to the 4th divided by x to the 4th minus 2x cubed. Now, when we were doing work last week, I told you, always make sure that your largest exponent is what? In the front, and also positive. Okay, so let's think about that for right now. Now, what do they all have in common, or do we want to rearrange them already? Would that help out? Maybe? I don't know. Let's do that. Negative x to the 4th, negative x to the 3rd, and a positive 6x squared. Largest exponent up in the front. And our goal is to make that largest exponent a positive, because that only makes things easier. So looking at only the top for right now. So let's work with the top. So this is my original problem. Negative x to the 4th minus x cubed plus 6x squared. What can I factor out that they all have in common?
Squared.
X squared.
Squared.
An x squared.
Can you do a negative x squared?
Should we do a negative x squared? Yes,
Yeah.
because taking out a negative x squared allows this to be a positive, and that's what you want. So if I take out a negative x squared from a negative x cubed, what do you have left over?
Plus x.
Plus x. And what do you have here?
Minus 6.
Minus 6. And remember, you could always go back and check, is this times this going to give me that? Is that times that going? The negative times the negative will give me that positive. Perfect. Now look at this. Can I still break this down? Yes. What two numbers multiply to 6, a negative 6, and add up to a negative 1? I mean, to a positive 1, so sorry. Multiplies to a negative 6 and adds up to a positive 1. 3 and 2. So negative x squared, x minus 2, x plus 3. Do I have to divide by something, or is that it? That's it, right? Perfect. So there's the top. And now let me look at the bottom. Who can I factor out in the bottom?
X squared.
Anything else?
A negative.
Anything else?
An X.
An x, but how many x's? It's not x squared, but it's x cubed. Because this one has 3, this one has 4, so I could actually factor out an x cubed. So what's left over when I factor out an x cubed? X minus 2. Beautiful. So that's your bottom. Let's rewrite them one on top of the other. Negative x squared, x minus 2, x plus 3, over x cubed, x minus 2. So for right now, and I'm wondering if you can be able to see everything, but who can I cancel out? X minus 2. Now, I need you to understand this, so look at here right now. This is negative x times x, x plus 3. This means x times x times x in the bottom.
So we have to break it down.
You have to break it down. So can I still eliminate an x and an x, an x and an x? So your final answer is negative x plus 3 over x. So once again, this negative x squared comes from x times x. This x cubed comes from x times x times x. So if you could still eliminate some x's there, that is perfect. This is your final answer right there. So example number 2, they only gave you one fraction. In example number 3, they're going to give you 2 fractions. So now you have 4 sections. Fun. And the crowd goes wild. Woo! No, you guys aren't excited about it? It's so sad. Just messing with you. So now they're going to give you something that looks more complicated, but it's the same thing. Third, minus 5x plus 6 times x squared minus 9 over 2x to the 4th plus 14x cubed plus 24x squared. Man, could that be any longer? Alrighty, so now I have how many things that I need to work with? 4, before you could start getting rid of stuff. So one at a time. First one, 2x squared minus 4x. What can I do here? Who can I cancel? Who can I eliminate? Who could be factored out?
2x.
A 2x. When you factor out that 2x, what's left over?
Minus 2.
That's x minus 2. So I have 1. Now let me do x squared minus 5x plus 6. Last number is 6. Middle number is -5. 1, 6. 2, 3. They both have to be.
Negative
So then it's going to be who?
2, 3.
X minus 2, x minus 3. So I did the first fraction, there it is, and even though they're next to each other, I'm just trying to factor them out before I put them one on top of the other. So let me do the second fraction. Have x squared minus 9, and that right there is a difference of squares, so my answer is the square root of 9 is
It's
3. So x plus 3, x minus 3. You have the right idea. So I did the top, but now I have to do the bottom, which looks like it's going to be lots of fun. I think, I don't know, maybe I'm wrong. Plus 24x. So who can you factor out from that 2x to the 4th, 14x cubed, and 24x squared? 2x squared. 2x squared. Because this guy has 2, this one has 3, this one has 4, I could take 2 away from everyone. So when I do that, this becomes just what?
2x squared.
X.
X squared.
X squared. 14 divided by 2 becomes a 7x, and 24 divided by 2 becomes a 12. So, can't do anything there, but can I still do something inside? Yep. 12 and 7, 1, 12, 2, 6, 3, 4. They both have to be positives. So, I have
3 and 4.
3 and 4. So 2x cubed, x plus 3, x plus 4. So this problem gave me the job of doing the factoring of 4 different things. So let's put them where they belong. This one is this one, so it's 2x, x minus 4, just kidding, x minus 2. This one goes in the bottom. X minus 2, x minus 3. This goes on top, x plus 3, x minus 3, and this goes in the bottom. When it comes to problems like this, I need for you to understand that it doesn't matter if they're directly one on top of the other, or if they are, as long as it's top and bottom, it doesn't matter which fraction it is. If it's the first one or the second one, they could be 1 and 1. So here I have an x minus 2, and I look at the bottom, if they're an x minus 2. Yes. I have an x plus 3 on top, is there an x plus 3 on the bottom?
Yes.
I have an x minus 3 on top, is there an x minus 3 on the bottom?
Yeah. So,
Right there. Now, I still have a 2x and I have a 2x squared. This 2x squared means 2 times x times x. Please don't forget that. So what does that tell you? Who can you get rid of?
both an X.
The 2x and the
2.
2x. What's left over on top? A 1, because there's nothing. But what's left over on the bottom?
X squared plus 4.
It's just an x and then an x plus 4.
You can't combine them.
This, if you do x squared plus 4x, yes, because remember the x would go to both of them. So this is your final answer. All that just comes down to that. Okay. Beautiful or no beautiful?
Takes long.
It takes long, it does. That's why there's only 13 questions versus 20.
Yeah, I like that.
2x squared plus 5x plus 2 over 4x squared minus 1 times 10x squared plus 5x minus 5 over x squared plus x minus 2. So start working on those, see what they have in common, see what could be factored out. have the work for the first fraction up in the front. But first, try it on your own before you look up here, so you can kind of see, oh, would I have factored those correctly? So you couldn't factor anything out from the 2, 5, and 2. So then you have to multiply the first times the last. When you look at the first of the second fraction, what can you do before you do anything? Factor out a 5. Very good. So make sure you factor out a 5 first. Make the job easier. Makes everything smaller, making it more manageable.
So we reached like -1 since you factored out 5.
Yes. Mm-hmm. 2x squared plus x minus 1. And then you have to do what we did here, of taking the first number times the last one. Are there any questions on any of these factorizations? So the multiplication is just, you have more things than just having one fraction, because now you have 4 parts instead of just 2. That's the only difference. But it still works the same way. You factor, as long as there's something on top, something on the bottom, you should be able to eliminate those.
What happens if like everything on one side of the multiplication cancels out?
It's okay. It doesn't, we're okay. As long as you have something paired on top with the bottom, whether it's in the same or in the second or in different ones, start. Questions on any of the factoring? Is everybody okay? Do you agree? I could have made a mistake because I'm human. As much as I love this, it's still, sometimes I'm like, I'm such a pro, and then I make careless mistakes. Just like in anything. So let's start to see. I have a 2x plus 1. Do I have a 2x plus 1 in the bottom? Directly right underneath. I have an x plus 2. Is there an x plus 2 on the bottom? Yep, right there. I have a 5 on top. Is there a 5 on the bottom? Nope. I have a 2x minus 1. Is there a 2x minus 1? Yes. I have another x plus 2 on top. Is there an x plus 2 on the bottom? So your final answer would be this, because this is what did not get canceled. Did you have a question?
Yeah,
Yes, sir.
what's your second fraction? How do you get the top part?
The top part? So I looked at this first. All of those are divisible by 5. So we factor out the 5. And then I ended up with 2x squared plus x minus 1. Since I have a number in front, you have to multiply the a times the c, the front times the last. And that's, you know, this kind of factoring, right? And then don't forget, because you multiply by 2, I have to divide by 2. The 1 doesn't. It goes to the front. The 2 does, so it becomes a perfect 1. There is one more type of thing that deals with division. It's very similar to this, except you have to do one thing first.
Wait, Miss Pena.
Yes. Tell me.
Where did you get the x plus 2?
It's not x plus 2?
Shouldn't it be x plus 1?
Yes, I'm sorry, it's right there. That should be an x plus 1. Thank you, I knew I had something. This here should be an x plus 1. When I wrote it from here to here, I did not write it correctly. So it is an x plus 1. Right there, x plus 1. That should have been an x plus 1. Thank you. See, I told you I make mistakes. You didn't believe me. Mateo just slapped me in my face. Just kidding. All right, so the last example deals with division. Once again, same type of thing. You have to factor to eliminate, except in division. And let me do it here because I have room. Let's recall division when you guys were in elementary. If they told you, hey, what is 2/3 divided by 1/5? Do you remember what you had to do? Would they do cross multiply?
I thought you multiplied it across.
You're supposed to keep, change, and flip. You would keep the first fraction, change division to, and then you would flip that one. And then you would do like 10/3. Do you remember that? Well, if you don't, remember not KFC, but KCF.
Wait, key?
Change, flip. Key, change, flip. And it is like a cross multiplication, like that's a 10, that's a 3, but how do you know where you put it? If it's on top or the bottom, but really just keep this in mind, key, change, flip. So this is what we're gonna be doing, but with polynomials, expressions. All right, key, change, flip, key, change, flip. We're good? Not good? Still looking at it? So example 4, simplify in division. Example number 4, simplify in division. They're gonna give you the problem, and it's gonna look like 4x squared minus y squared over x squared plus 4xy plus 4y squared divided by 4x minus 2y over 3x plus 6y. So divided by. So my recommendation is you rewrite it correct at the very beginning, and then it just becomes like a problem that we were doing before. That's the only thing you have to do. So this is going to say, so we keep this, we change the division to multiplication, and we flip the we flipped the second fraction. Always like that, keep, change, flip. So now it becomes a problem like the ones we were doing right now. This is the only change you have to do in division. So when we look at the first fraction, and we look at the numerator, this is a what? Can you take the square root of 4? Can you take the square root of 1? It's a difference of squares, so this becomes what?
X minus 2,
2x minus 1?
y.
Two.
1y. Yes, 2x minus 1y. And 2x
Plus.
plus 1y. Perfect, sorry. Falling off the wagon. Whew. And the last problems. Now this one, can I factor anything out? Nope. They don't all have an X, they don't all have a Y, so this, we just need to be careful when we do this at the very end, but numbers that multiply to 4 and add up to 4, 1, 4, or 2 and 2? 2 and 2. So this becomes X plus 2Y, X plus 2y. When they look at 3x plus 6y, what do they have in common? A 3, very good. So this becomes x plus 2y. And then I look at 4x minus 2y, what do they have in common? Oh, 2, right? So this becomes 2x minus 1y. And then you position everything where it goes according to the way we rewrote it. Don't go back to the original. You're sticking with the multiplication. You're sticking with the multiplication. So this is 2x minus y, 2x plus y over this one, which is x plus 2y, x plus 2y times 3x plus 2y over 2 times 2x minus y. So it's just a problem like the previous example. You start looking, crossing out all that you can. I have a 2x minus y on top. Is there a 2x minus y?
Yeah.
Yep, right over here. I have a 2x plus y. Is there a 2x plus y?
Yeah.
Nope,
No.
there's not.
Oh, yeah.
I have an x plus 2y. Is there an x plus 2y? Yes. So what's left over? 3 parentheses 2x plus y over 2 parentheses x plus 2y. It is a lot of work. I agree. So similar thing, yes? One last thing, unless you guys want to do one after this one. What time is it? Okay. When they give you a problem like this, and should be the last one unless you guys want to do another one after this one. 24 plus 10x minus 4x squared over 2x squared plus 13x plus 15 divided by 2x minus 8. So they only give you one fraction. This is not a fraction, but can we make it a fraction? By putting it over 1. So I don't want for you to be like, where does that belong, on top or the bottom? Right now it's on top. But when we have to do the rule of keep, change, flip, this is going to become 1 over 2x minus 8, 2x squared plus 13x plus 15 on top, 24 plus 10x minus 4x squared this is the problem that I need to do. So once again, they're gonna give it to you just by itself. You need to put it over 1, and then you have to do the same thing.
So you're gonna have to do it for both, whenever that happens,
For which vote?
for both, sides.
When that, do,
Because you switched, the first part.
oh
Yeah.
shit,
Yeah,
sorry. I was not supposed to, and excuse that. The first, it stays the same. I don't know why I switched it. Just kidding. You're not supposed to switch, only who? Only the second one. I'm so sorry. Oh, gosh. I'm thinking of something else. The first one stays, so we keep, we change, and we only flip the second one. We keep, we change, and we flip. If I have to factor the first top, what would be recommended that I do? Put it in order, so I have a negative 4x squared plus 10x plus 24. Can I factor anything out from there? A negative 2, very good. If I factor out a negative 2, this becomes a 2x squared. And then
Minus 5,
x and a minus
minus 12.
12. Okay,
Where'd you get it? The 12?
the 24 divided by negative 2? Negative
Oh,
12. 2 times negative 12, negative 24, and it needs to add up to a negative 5. So that's going to be 3 and 8. Who has to be the negative? The bigger number, because it's a negative 5. So negative 2, x plus 3, and an x minus 8. But because I multiply by 2, I have to make sure and I divide by 2. Does this 3 divide by 2? Nope. So it becomes 2x plus 3. Does this 8 divide by 2? Yes, that becomes x minus 4. So here's the top. You look at the bottom one. 2x squared plus 13x plus 15. Can you factor anything out right there? No, right? So 2 times 15 becomes 30. My middle number is 13. 130, 215, 310, or 56. What's going to give you that 13? 310. So x plus 3, x plus 10, but don't forget you have to divide by 2. So this guy becomes 2x plus 3, and this guy becomes x plus 5. Now, when you look at this, what are you going to be able to factor out? A 2, right? I'm not going to do it because then I'm not going to have room to finish off the problem in this page, but when I rewrite it, I will. This top became negative 2, 2x plus 3, x minus 4. The bottom became 2x plus 3. Battery's going down. X plus 5. Top is a 1, and the bottom you said we could factor out a 2, which gives me this. Very good. And then who do you cancel? 2x plus 3, x minus 4. There's a, can I factor out those 2's, eliminate those?
Yes.
Yes. So on top, what do you have left over? A negative 1. Just don't forget that negative. Over x plus 5. So that right there would be your final answer. So it is a lot of work. You just need to not lose your patience.